Start recording. Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. Of course, I gotta move this headphone down, apparently. Yesterday, we did some work to implement sort of state saving and restoring for live code editing in loops. Now that we've put in dynamic allocations, as opposed to just using a single block allocation, which you used to kind of just read and write out. But we have not debugged it yet, so really all we are trying to do today is just go actually do the debugging work and make sure that's all working properly. That's all. So yeah, let's get started. Today is day 344, as the little counter sort of says here. If you want to start with today's code that I'm starting with, you can go to day 343. Alrighty then. There we go. Let's take a look at where we were at. Now, really, what our problem was is we didn't have any specifically crashy things to deal with. It's just that we have a problem where when we go to reload, it looks like we get into some kind of a state where the game is still running, but it's not really running properly. So although we must be saving and restoring our blocks to a certain degree, something slightly off is happening, so we end up ruining the game when we go into a loop. And you can kind of see what happens here. If I click the loop thing, you can see the game sort of freezes here. But unlike what we would maybe potentially expect during a normal freeze, we are actually still executing fairly reasonable code. So we're not actually frozen in the sense of like some obvious loop that we just got stuck in. If we break at various times, we're in completely different parts. So what appears to be happening is we appear to be still running the game just fine, but something about our state restoration that we did now no longer allows us to actually restore proper functionality to the rendering. So it's as if our game really wasn't still running effectively as far as what's presented to the screen, even though for some reason the code is actually running, right? And so yeah, I mean, we haven't actually stepped through any of this code yet, so the first thing I just want to do is take a brief look at stepping through the code. The other thing that we need to do is we have to verify, because there's a couple things we haven't quite implemented yet. For example, handling allocation and deletion inside the recording block, which may be happening for all we know, so it's not 100% clear that couldn't be causing a bug, but in theory it should crash if that had happened. But anyway, we have that problem of having that freeze. We should at least step through the code and make sure we have some idea what's actually going on, right? And so let's take a look here. Here's the stream out. You can see it happening here. We're going to loop through and see what the blocks are that we're writing out. I just kind of want to get a feel for how many of them we write out and what they are. You can see we have sort of our base pointer and our size here. That's a 64 meg chunk that it's going to write out, which in theory it's writing out here. And yeah, let's take a look at what bytes written is as well. Oh, well, that's not a good sign. I wonder if we're getting some kind of an error here. Ah, there we go. Well, it looks like that is a pretty obvious reason why things are not working properly. We didn't use the right handle. So yeah, that maybe we should check our return values here. One thing that is kind of true, and I am guilty of this a lot, is that I tend not to be super careful about error handling in parts of the code that aren't user-facing. So for example, this is purely debug feature, so I don't care how robust it is. So I tend not to do stuff like check return values of write file or whatever. You know what I mean? But one of the downsides of that, maybe it saves you some time, but it can also cost you time, because if we had just done that, if we had put in something that would at least do assert that was coming back true or something, or that we wrote the amount that we thought we were going to write, that would have caught that error for us without us having to look for it. Now, granted, maybe that doesn't matter because it wasn't like we looked for it for very long, but it's just worth noting that that's the kind of thing that can happen. Sometimes, even though you don't actually care about a particular piece of code in terms of robustness, and so you don't do that error checking. It may be that you still want to put the error checking in just to give yourself the benefit of not having to debug something that could have been called for you. So now that's actually getting written out in both cases, which is what we would hope. So that's all good, and of course we can't check that one because MSVC refuses to show it to us. Okay, so now at least we are writing that out. Oh, and hey, that turns out that was our only bug. So good. So now we've got our loop left code editing working properly with dynamic allocations. And that might be fine. Like, again, this is not a feature that anyone is going to run in the actual game. It's strictly a thing that we do for ourselves so that we can implement things if we want to, if that makes sense. And I guess what I would say about that is, it kind of depends on what we want to have happen, I suppose. Do we want to make sure that we can always use loop live code editing, even in circumstances where it might be a little bit touchy, or I don't know what. What I will say is it's a little bit weird there that it got a lot slower the second time through. I am a little curious about that. Like the first time we ran this, it didn't do that. Oh, you know why? It's because now we're actually seeing the writes. Before we weren't actually doing the writes, and now we were. That's probably why. So anyway, that's that. And now we're doing those. Now we're sort of working properly there, and we have to kind of decide what we're going to do. We also have sort of a situation here that we might want to take a look at, which is how fast it is to do those state restores. And that's sort of a separate issue. But the first thing I want to look at here is I just want to look at how big those files are. So if I think this code, yeah. So here's our loop edit 1 input right there. You can see it. That's the file. The states stuff I don't think we actually do anymore, so we could actually delete all those files. So if we have these loop edit things here, and we want to have those actually work efficiently, 363 megabytes for one of these, a lot of that is probably in the asset store, right? Our asset storage system right now allocates 256 megabytes as its block of asset processing. And if you thought about that, it's like, well, does that really need to get saved and restored anyway? In fact, the whole asset system really wouldn't have to get saved and restored at all. The asset system itself isn't, entirely sort of, it serves itself properly in terms of a cache, so it doesn't really need to get saved and restored. If it didn't get restored when you did the loopback, it wouldn't actually matter, right? It wouldn't affect anything. So if you look at how much we're saving there to the loop edit, yes, it's a lot less than it was before. Before we were saving out a gigabyte or something like this, because that's how much the total block was. So the fact that we're only saving out the blocks we've actually allocated so far does help a little, but we're still saving out a bunch of data we don't actually need to save out. And so it does raise the question of whether or not we would want to do something a little fancier here in terms of what stuff we want to save and restore and what stuff we don't want to save and restore. So if we were to take a closer look at this, for example, let's say I go to the asset system itself. I'm going to take a look in here. So if we were to go to the asset system itself where we do allocate game assets, you can kind of see here that, that if we just take a little bit of a second to look at the allocate game assets call, you can see that what it does is it's actually kind of grabbing one giant block off of the arena it's given here. And all it really needs is that. From then on, it's not going to do anything else, right? Because it allocates its own memory and does its own stuff. So if we wanted to, we could take the asset system entirely out of the equation, because it also doesn't really do anything other than, it doesn't have any other sort of like hooks into any systems or really anything else in particular it's doing. And it can probably be treated, for the most part, just like sort of a separate system that doesn't need to be really worked with in any more specific of a way, right? So we probably could take that out of there. Now, it's a little bit iffy if we do that. The reason for that is I'm not sure exactly how that would interact with our, we've got sort of threads that are operating inside the asset system there. And those threads obviously are doing sort of asset load work. So you can take a look at what happens inside load asset work calls, for example, like one of these guys. You can see that the way that that's working is inside here, we have to do stuff which may be touching things in the asset system, which means that if we were to have these tasks saved and restored for some reason, which is sort of what would happen to a certain degree if we were loading across the save restore boundary, we would get into a situation potentially where the asset system would be out of phase because its memory wouldn't be getting restored, but the memory for this other set of stuff would be getting restored. I don't know if we really care about that too much because, again, probably other stuff will break at that point anyway, meaning what we probably want to do when we do loop live code editing is shut down all threads, then do the loop point, and then we want to wait for drain out, then do the loop point and then go forwards from there. So it seems like it's still probably a reasonable thing to do to say, let's take maybe the asset system out of that. Let's just take the asset system out of the general pool and let it just do its thing, right? And so if we wanted to do that, what we could do is say, well, we've got these memory arenas. Maybe we can just say on the memory arena something that has to do with we don't want any allocations that come from this memory arena to actually be save restore, right? We want them to bypass that process and not be involved. Well, we could do that pretty easily because the way that we sort of structure the code right now, where we have these sort of memory blocks, is we could inside here say, okay, maybe there's some flags on this memory block, and the flags on the memory block could control things like whether or not it was going to get saved out, right? Something like this. That's the wrong place. I meant there. There we go. Those flags on the memory block would say, hey, this is some extra information. And so when we go to write it out, we could, when we go to allocate it, we'd put the information in the flags from the person who did the allocation. And then when we go to write it out, we could check the flags and say, hey, if this is a block that's not supposed to really be saved and restored, then just don't do it and save us the trouble. So we could say, all right, so there's Win32 memory block flags, right? And we can just say, I guess we can just probably call it mem flags. Win32 mem flags? I don't know. Something like that. Win32 memory not restored or something. Not restored is probably my best one so far. Let's just call it that, let's say. And so what we could do here is when we actually pass stuff down to the allocator, right? Because when we know when we're getting an allocation call, right? They have to call this allocate memory thing. So what we could do is have it pass down flags here, and when it passes down the flags here, those would go to our allocator, and we'd be able to set them on the memory block, so the memory block would know. So right here, we could just say, okay, the flags. There's the flags, right? And then we would be good to go. Now, in this case, where we do the allocations here, we need to know what flags to pass. And so presumably, we can pass those flags however we want. Presumably, they would just be stored on the arena. But I guess I would point out we could also pass them in some sort of other ways, I suppose. But I think that's what we want for the most part. So I think what we want to do is just say, let's store in the arena itself, up here. Let's store in the arena itself the flags that we want to pass. So these will be the allocation flags. And then we, by default, those would be initialized to 0, which is what we want, because we don't actually typically want much of that to be happening. But in the case where we wanted to take a specific arena out of the allocation pool, then we actually could, right? And similarly, the push buffer here for per frame arenas, I think that would not want to be saved and restored either, because that's just a temporary thing per frame. So we probably don't want to restore that either. So we just set it to not restored here and leave it at that. So now what we should be able to do, of course, if we run things now, there'd be no difference, right? Nothing particularly odd would happen if we did that. right? We still get exactly the same behavior because we're not actually looking at that flag. So we don't have any, we don't have any expectations about what's going to happen there because we're never looking at that flag anyway. But if we have write file here, then we would just put in here the fact that we don't want to save this block at all. So if the source block flags happens to equal, let's see here. Where did you go? There we go. So if the source block flags happens to set, if the source blocks flags happens to have the not restored flag set, then we just don't write it out. Now we don't have to do anything else to it because when we read in the blocks, it just won't be there. So it'll naturally leave it completely alone. So now we know if we do this, we'll have like 1 that's going through there, right? Oop. How about I make that be the right order? There we go. If we do that, we'll now at least know that 1 block is going through that, and that's just that temporary memory arena for the rendering stuff. And that's all fine, but what we want to do is take that bigger block out of there, right? Because again, we've got this sort of loop edit 1 input HMI. It's still really large, probably much larger than it actually needs to be. And that's also what kind of causes that hiccup there during the state recording. You can see how long that was taking. So what we might want to do again now is go into the asset system, and we could just pull the asset system out of that process entirely. So what we can do here is say, all right, the asset system is going to have, we know that it has its own memory, or rather will have to have its own memory. So we should be able to go here to, where are you? Yeah, here we go. We should be able to go to this, that's not it. There we go. The asset structure, and just say, all right, since we know that we want this thing to have its own kind of memory pool that's outside of everything else, what we can do is say, all right, we'll put a memory arena in here for the asset system's memory, and we'll call it maybe non-restored memory. And then what we can do is say, all right, in the non-restored memory, we're going to have the asset system when it gets initialized. Instead of using the arena that's passed in fact, we could just take that out entirely. There could be no actual arena passed into the asset system. The asset system could just sort of generate itself from whole cloth. Because if we take a look at what's actually happening in the arena here, you can see that it's really not used for pretty much anything other than the asset information itself. So what we could do is say, all right, forget about that, right? Let's say that we have a memory arena. And it's just going to be the non-restored memory from the game assets pool itself. And then all we have to do is, instead of doing a push struct, we just have to do a bootstrap. Right? We just have to do the same thing that we were doing before. And when we do this, then we will get the situation where the memory arena does its sort of bootstrapping, and it sort of creates a new arena for the allocation and makes that arena be something that's inside the asset struct itself. All right. So that's about it for that. We don't need this anymore. But what we do need, what we do need beyond that, because now this should work just fine, but it's still going to be an arena that's a tracked arena. So if I do this, I'm still going to have it going through the standard arena process where it's getting written out. And so I don't want that to happen, so what I need is some way, right? I need some way specifically of going in there and setting that arena to not record its memory. And I would like it to not record the game asset struct itself either. So in the bootstrapping process, I would like to have, during the bootstrap, a way of setting that thing. And so if we take a look at the bootstrap push size here, I would like to be able to pass, like we passed the minimum block size as well, I'd like to be able to pass the flags here too. I'd like both of those things to be able to be passed. Now, I don't like how confusing that is, where you've kind of got these two things here that are sort of like just numbers and plus the offset. It looks like it could be something, that could get messed up. So I might want to do something like memory bootstrap params. So it's just a little clearer what's going on. Here's the allocation flags. Here's the minimum block size, like so. And then what I can do is say, all right, when you bootstrap, you pass the memory bootstrap params. And that way that can get set up properly. And the way that would work is, OK, when you do a bootstrap here, right, we'll set both of these allocation flags to be bootstrap params. Allocation flags, bootstrap params, minimum block size. And there we go. Now I just need some way of getting a default in there. And pretty much none of these other ones who do bootstrapping are going to want to really set anything beyond the default. So probably what I want to do is take exactly the same tack that I took with the other part here. So you can kind of see what we did with like no clear and these sorts of things. And there's the default arena params. What I want to do is do like a default bootstrap params as well. And while I'm at it, let's move this up a bit. And why I didn't call that arena, I don't know. There we go. And so all I want to do there is I want to take the bootstrap params and I want to set them to the whatever they should be by default. And in this case, we really don't have to do much because we already make 0 work correctly with them. So as long as I just clear the bootstrap params first, that would be the default. And that's fine. So what I could do here is just say like, all right, the bootstrap params is going to be default bootstrap params, and that's it. Nothing further to be done. And then everything should compile properly. But like I said, in here, we want to actually pass some. So in this bootstrap push struct here, I'm just going to say like, oh, OK, I want to pass some params. The params I want to pass here are just like a non-restored arena, right? And what that would be is just something, as part of the bootstrap params settings. That would be, maybe I should probably get these guys somewhere down here. There we go. That would just be something that essentially takes the default, whatever the default is, and sets that particular flag. So I'm going to go ahead and say non-restored arena. And I'm going to make that at the default. Oops. Bootstrap params. I'm going to set the flags equal to now that I think about it, why did I make this a Win32 memory flag? When you have to pass it in, that's just where my head is today. When you have to pass it into something, it can't be Win32. It's going to have to be in the platform layer, right? It's part of this thing. So it's really a platform memory block flag. And it's platform memory not restored. So don't know why I did that. All right. So anyway, the allocation flags being set, we wouldn't need to touch the other parts of it. And then I just need to change these places where I had erroneously labeled it as Win32. So let's go here. So now the asset system is not being included in there, right? So during the save and restore, the asset system's 256 megabyte block that it allocates, which is, again, not really necessary to restore, or at least we hope not. Or is it? I may be very wrong about that. So it looks like we do have something we need to restore from there, which I suppose we could. But that part which is not necessary to restore wasn't being restored, and except for that one problem, it means our loop edit code, our loop edit sort of size we have to save out is dramatically reduced. Now the in-flight generation count thing, this was strictly to allow us to do some stuff that we don't do anymore. Originally, when we first did Handmade Hero, we had the asset system set up in a nice way that there was a predefined time when assets got flushed out so that they wouldn't be flushed out when they were being used for rendering. Unfortunately, we then decided to try doing the ground chunk thing, which really was way more work than it was worth, because it required us to have the asset system know when things were in use and when they weren't. And this is all that really was for. Now, why the asset system itself is tracking that, I mean, this may just be a case of we could still preserve the feature and just move those out to somewhere else, right? And that wouldn't really be a big deal. I also don't know. Yeah, I believe the same thing is true for most of these things, right? Like we had to do a bunch of things here that really we don't probably want to be doing, but that came in as a result of the fact that we wanted to support this process that we no longer actually want or need. So it may actually be a good idea to just get rid of that. That might be better, right? Because I'm really not sure that we want to keep supporting that. If we didn't support that, there's pretty much no chance that we would ever have a problem, because we know that we'll always have enough asset memory that we'd never page out something that was being used on this frame, right? So really all of this stuff is really not necessary at that point. And it does sort of mean that we're having a lot of complexity there that we don't actually need. And I don't know like what the best way to deal with that is, but it does, you know, like just my feeling about that is I would rather not have that be the case, right? That's just what I would prefer. And you can see that the only reason we need it, right, is during acquire asset memory, we go and grab things. And all we were doing here is we're saying like, oh, you know, the asset memory, if you're going to take something, don't take from an asset who's still being used by someone. But really, we don't need to know that anymore because the only person you could be being used by is the current frame's worth of memory, right? And so it just feels like a really not necessary thing, if that makes sense. So the question is, the other question I suppose there is, could generation has completed be made into something a little bit simpler now that we know we don't have multiple threads doing sort of asynchronous render tasks that are unrelated? And I'm not sure. I'm not really sure. But I'm going to take a look at this. So let's say we were to get rid of this code. Who actually uses it at the moment? Obviously, begin asset lock, end asset lock. If we just said there's no asset lock, although this we probably do need here potentially. But if we just said there's no asset lock, who actually uses this stuff? So begin generation just increments the ID. End generation just removes it from the list of people who are currently using the lock. Who else? So result can presumably, in this case, if we're just for testing purposes, result can just be 0. And in terms of generation has completed, we could also just always return true. Because we could just say, yep, you can always use memory from anyone you get, right? All right. And so again, there's really, there's no chance that that would be necessary code at this point. And again, the reason is because all that code, the only thing that code was actually doing, there was no point to that code at all other than to prevent you from evicting an asset when something in the renderer might have been using that asset, right? That's the only reason that we were doing it. So we essentially had a begin and end lock of sort of not a real lock, but a sort of conceptual lock where during the rendering of a frame, you would basically have to ignore any asset that was being used on that frame until the frame rendering completed. So yeah, so that's the current state, and I feel like I'm not sure whether I want to try and preserve that functionality or not. I guess I would say that in general, I like it conceptually because it does seem like the kind of thing you might want to include. So I'm just wondering, could we perhaps just have that be stored in something that was, just allocate that from something that was going to get restored, and then we wouldn't have to worry about it. For example, we could put that in the transient state and leave it at that, right? I just don't know. Let's take a look at what would happen if we did put it in the transient state. I'm just curious. So let's say that we put that over in the transient state, and we can always, again, still delete it after that. So I'm just going to take a look and see. I am going to snip this out and place it in here. Very well. And now I am going to... Does this get cleared, by the way? Yes. And now I am also going to change all of these calls back to doing what they were doing before. But I'm going to have them get it off of the transient state. And I'm not thrilled about that back pointer according to the comment, but since it's already there, I will use it. Use of undefined structure. Yeah, well, that's probably true. I agree with that. Question is, can I put this somewhere else? Handmade asset. Begin asset lock. Identifier not found. Oh, because these guys are all in line as well. Yeah, so I guess not. This is that stupid C thing that I absolutely hate, which is having to deal with its kind of vagaries in this sense. I suppose I could make sure the trans state is known about here, but I don't really know. That does seem a little bit squirrely. Again, this is one of those things that programmers should literally never have to deal with, but unfortunately, C++ being what it is, you do. So if I have the transient state, I suppose I could just loft that up somewhere else and have the asset stuff be defined after it. In theory, this isn't really pointing to very much else. So, I could just pre-declare the game asset pointer, and then we would be done. The asset system itself, of course, getting included right here. So, literally I could just do something kind of squirrely like, that. Not my favorite thing, but, what are you going to do? Task with memory. Can also be moved up. And so now we do have, there's a little bit more that we haven't done here. There's the begin generation stuff. Begin generation. That I did have to comment out before, and so now that also has to get commented back in. Again, nothing particularly weird happening here other than just I have to use that pointer. There it is. Next generation ID. It looks like I did not move one of the things I should have moved. Next, and in fact, there it is. All right, so let's go back to the transient state and put that in as well. And I think that's just about it. And just a pro tip, you should probably set a pointer before you use the pointer. Just something to think about. I don't know that this actually needs to happen here, though, because in general, if the trans state's cleared, we don't need to clear it again, right? It'll just get cleared. So I think that's mostly all we need. And so now the locking should be restored, saved and restored. Which I can't think of any real reason not to continue supporting it, I guess what I say. It's a little bit of code complexity that definitely doesn't need to happen. And so we may end up pulling it out at the very end, when we get further down the line and are like, okay, the game's like, roughly where it should be in general, and now it's time to go maybe clean up some code stuff that now that we know everything is what everything is. I could still see cutting it. But at the moment anyway, we might as well just leave it in there because, I don't know. I suppose it helps us potentially in some weird circumstance I can't think of. I can't think of any way it could ever actually help us because either you have enough memory to store all the assets for the current frame, in which case no asset's going to get evicted on that frame anyway, or you don't, in which case you can't render the frame. So it just doesn't seem like the kind of thing that we actually need. It's really only necessary, as far as I can imagine in my head, it's really only necessary for the circumstance where specifically that what you want to do is have multiple renderers running concurrently. And so one render could be sitting there chewing through lots of different asset requests, moving through the least recently used pool, while another renderer is still kind of sitting there, hasn't touched any of the assets in a while, but is still pulling from them, doing some background rendering. That's the only time you actually need anything like this to occur. So yeah. That's about the only thing I can say about that. All right, so now we have a situation where we're certainly much nicer. Like you can see here, the loop live code edit file is now, like for that loop, was 32 megabytes. So even though probably we don't we definitely don't need to store 32 megabytes of memory because the memory, some of that memory isn't changing and stuff like that. One of the nice things about it is that now we do know, okay, we're not saving memory for stuff that we just don't care about getting saved and restored. And before we were. Now at least we're only saving memory for arenas that we actually think are participating in stuff we want to loop live code edit, and that seems like a nice win. Now, that's just about all we need to do with this system. Like I said, we now have sort of a question about whether we want to go a little further with it and see about handling memory block restoration in the case where we malloc and free something, essentially, or virtual alloc and virtual free in this case, something in the middle of the recording. And I don't know that we actually ever have that happening now. In theory, we should crash if we do. So in theory, that means that during the sort of test runs we just did, that wasn't happening. Now, that makes a lot of sense why that wouldn't necessarily be happening. And the reason why it makes sense that it wouldn't be happening is because the only thing that would really be getting allocated and deallocated during a frame at the moment is just like temporary memory or something, right? So it's very unlikely that we would have a block that would whose persistence would change across the recording boundary. But that won't always be true. So in theory, that is something that we might want to care about, because otherwise our loop live code editing would kind of like crash someday, and we would be unhappy. Now, what we will need to do here is if we allocate memory, like if we want to support this, if we allocate memory, what we need to do is know, OK, when we allocate memory, if we're going to go back to the loop point, we need to get rid of that memory, right? That's what we would need to do. And if we deallocate memory, then what we have to do is just not actually deallocate it, right? The second one's pretty easy to do. All we would do is when we go to deallocate the memory, we would just say, if we're in the middle of recording, just don't free the memory. In the case of memory that we allocate, what we would probably do is say, well, OK, if we allocated memory that's inside a record block, let's set a flag on it to let us know that actually when you go to restore the pages, delete this page and pretend that you freed it, right? Seems pretty straightforward. So it feels like we should at least nominally implement that. Because we might as well. I can't see why we wouldn't. Yeah, I can't see really any reason not to. So while we're recording, right? While we're recording, when we allocate memory, what we'd want to do is anytime we're recording or playing back, if we allocate memory, we just want to mark it that if we jump back to a record point, free it, right? So we just need to know, are we recording or are we not? And so really, I just need some way of determining that. And then we would know, hey, if you're going to allocate this page, make sure that you free it later, right? And so then in here, we'd have platform, memory. In addition to not restored, it's like allocated during recording. Something like this. And technically, I don't know that we would want to expose this to the platform layer, because it's sort of just a implementation detail of the Win32 side of things. So I might stick a to-do on here that's like, maybe, and in fact, maybe we don't want to do that. Maybe we want those memory block flags to be more pure than that. I don't know. And since we've got plenty of padding in that struct, maybe I just won't even bother putting the to-do. I'll just do it a different way. So I'll just go here and say, there's just, 2 of these B32s on here. Use up one of those U64s of the pad and just say one of those is allocated during, allocated during loop or something. And so if it's allocated during looping, then that's one that would just get freed. And so what we could do is when we do our restore, so I'm pretty sure that's in here somewhere. let's see. So we've got end input playback, right? Win through to end input playback. So if we end input playback, we wouldn't want to free anything allocated during the looping because that's something that's now going to persist. So what we'd want to do here is clear that flag, right? We want to go through and clear the flag off the memory block. Like so. Let's see, went through to memory block equals do state. Oh, we actually got past that. State memory sentinel. Next, block equals block. Next. All right. So in this case, we're going to loop over the blocks, and we're going to say allocated during looping was false, so we just clear it. We don't actually deallocate the memory because we want to keep the memory around. We're going to continue playing the game from this state. We want to keep it around. So if we begin input playback, then at the point where we begin, we would want to deallocate all of that memory, right? So we'd want to say like deallocate all looping blocks when we go to begin input playback, because we want a clean state there, right? The same would be true when we go to, I guess the only other time we really care about that, begin input playback, we want to deallocate all of them. And when we begin recording input, I guess we don't have to do anything, because in that case, our memory state is our memory state. So when we begin input playback, that means we're hopping back to the thing. We want to deallocate all the blocks that were created during looping. When we end input playback, we just want to clear the flag so we wouldn't accidentally free them during a later loop session, right? And I'm trying to think if there's any particular time other than those where we would need to do something. I don't think so. So the other thing that we'd have to do is if we would have freed a block, we need to free that block if we end input playback. So when we end input playback like we do here, right, we'd want to set allocated during looping, but then we want to do like freed during looping, and we'd want to actually free the block. Right? So I think that we actually do want to do that. So something like this, right? So there I'm just saying, OK, let's have an iterator. We're going to iterate over these blocks. We're going to move to the next block regardless. But what we want to make sure we do is if we're going to free a block, we don't want to touch that block afterwards. So we want to make sure we have a way to do that. So then we'd have two here that's like freed during looping, right? Yeah, so I think that that's all we really need to do there. Now, if something was freed during looping and we're looping back to it, our deallocate all looping blocks call, which it looks like we only ever do once, so I guess that's just going to actually be this call, has to do the corresponding operation, right? So in here we would loop through all the blocks, and then we would say allocated during looping is what we would actually need to switch on. Right? So in that case, we do this. And the freed during looping is the thing that's actually going to get cleared. So I think that's it. And we could probably structure that a little bit more cleverly by just having a single thing that takes a mask. You know what I mean? So if we wanted to, we could be a little bit more clever there and collapse those two loops down to be like a, basically a, in fact, let's just do it. Let's just be clever there. Internal, like free, win32 free blocks by mask. Maybe we'll call it clear blocks by mask. I don't know what we'd call it exactly. So if you pass the win32 state in, and we do essentially this exact loop, if we imagine having a mask here and turning this into a flag, right, that's like looping flags, then we can just say, OK, there's a win32 memory block flag. And that's like win32 loop or mem allocated during looping to mem freed during looping. Right. And what we can then do is when we pass in a flag here, we can just say, tell me what you want me to look for when I free. Right. So what I do is go, OK, in the case where we don't free it, we're clearing it. But in the case where it matches the mask, then we are going to free it. And we'll check for the entire mask, just in case we want to look for two flags or something like this. And I think that's all we would really need to do. So then what we can do is in here, we'll just actually make the appropriate calls. So here we'd say win32 clear blocks by mask. We'd pass the state, and we'd say we were trying to do allocated during looping to false, and freed during looping is the free condition. So that's that. And then in the other case, we want to do it the other way around, right? Where did that go? Where are you, Mr. Loopington? Here. There we go. Did I just remove it? I just cut it out, didn't I? All right, well, that's not very smart. So we did win32 clear blocks by mask at the top of end input playback. But for some reason, I guess I cut it out of here for no reason whatsoever. Because end input playback needs to have it, but so does begin input playback. All right. It's just me having a little brain fart there. All right. So I think that's what we're looking for in terms of clearing. And now I just have to make sure that I go and set these things properly, which at the moment I'm not actually doing. Right. Oops, that's correct. There we go. All right, so let's go ahead and do the rest of this. So let's take a look at the deallocate memory call. The deallocate memory call we need to now pull out into something that deallocates the block so that we can have free memory block. So that we can have somebody else call it besides this routine. This is all we actually need to do, right? It's all there properly. We just need to actually call it or have it be callable as a separate function. There we go. OK. So I think now we're in good shape. The problem is this will do literally nothing at the moment. because, or it'll completely destroy the entire world. Because we aren't actually ever setting these flags, or at least I didn't think we were. Now, apparently we actually are. Probably we're not actually clearing that. I should double check that we are or aren't. Where's our Win32 memory block? Kate. Virtual alloc. Let's see here. Handmade, bitmap memory size, blah, blah, blah. There we go. Although those flags should be cleared. I mean, because virtual alloc will give us back a zeroed page. It's required to. So we should be able to assert that our looping flags are set to 0. So that means nobody should ever get freed here. Oh, hi. That was probably just an infinite loop. I was like, that shouldn't have done anything. So I guess, now that I think about it, is virtual alloc allowed to give me back the same page? I thought virtual alloc had to be zeros. Oh, wow, it's been a rough day. I can tell you that. Block. Looping flags. 0. There we go. So that was probably just the infinite loop there, I would assume. Let's double check to see if that's true. Oh, and not to mention the fact, yeah. I tell you, some days you just shouldn't be programming, and that is today, to be certain. So let's see here. What I want to do there is I need to check for the actual block sentinel, which I was not doing. So let's go ahead and fix that. Much better. So now that's okay, but we're not setting those flags at all. So I think the only other thing that I want to do here, should be almost out of time as well, is I want to have some idea of whether I'm recording or playing back or doing other things like that. And if I'm during one of those things, then I need to set my flags accordingly. So essentially what has to happen is during allocation, when I would do a deallocate or an allocate, I need to be able to mark the blocks here in the appropriate fashion. So what I want to do is say, all right, when I allocate memory, if I'm going to allocate memory, I always have to succeed, obviously, because I can't not allocate something. I have to hand it back. But what I want to do is say, if I was going to, if this was going to be something that was inside a loop, I need to set it with that Win32 mem freed allocated during looping flag. So I want to do is like is in loop, right? Then I would set allocated during looping. Otherwise, I'd set it to nothing, right? And then the same thing is going to happen for the free. What I want to do is say, if Win32 is in loop, right? Then I want to go ahead and check, and this should probably take the global Win32 state. Global Win32 state. If we are, then we're going to set it to be free during looping. And if we're not, then we're going to free it as normal. So now we just need a way to know, right? We need to know whether we're looping or not. So we essentially need some function here that's like, hey, are we in a loop? Are we not in a loop? And I believe that technically there's two ways, right, that we might be in a looping condition. If we're recording or if we're playing back, they will both jump back to the beginning. So really what we need to check there is we need to check whether or not we have a recording index or a playing index, right? And if we have either of those, then we are looping. I believe that would allow us to handle gracefully the condition where somebody does something during the loop with the memory blocks. That's about it for today time-wise. And thank you, Neil, for putting in exclamation point QA for me. I still have not on this machine. I keep meaning to, but I just haven't had a chance to like do the whole thing where I get hex chat set up to log to the Twitch stream so that I actually am seeing your tutorial on there. If I try to type anything into it now, it's like I'm not me, so it won't allow the QA, the #QA thing. So yeah, we should go find out what the black dot is as well. The black dot is pretty cool. I don't know when it started showing up, but we've never gone and tracked down what the black dot actually is. If you run the game, usually the black dot is there, but I think it may have been. Remember, we have a bug still on our to-do list that I postponed for occupation points. They're not getting created properly at the beginning, or people aren't placed on them correctly at the beginning. So I wonder if that killed our black dot. I really liked our black dot. I wish the black dot was back. It kind of reminded me of like the Atari 2600 adventure game, where there was that like secret black dot you could get, but I guess it's gone now, unfortunately. One nice thing about doing this different memory unit stuff is that now loop live code editing starts and loops really quickly. It's like it's mostly instantaneous now. Even on this hard drive, which is a 7200 RPM like physical disk drive, it's not even an SSD. So that's kind of nice. Neil, I'm scared to look back at my own library reload, not even looped editing, after I stopped using it for a few months. Probably 10 plus hours of debugging ahead of me. Yeah, I mean, some of this stuff is obviously things... I mean, like anything else, the whole reason that people reuse engines is because low-level code is hard work, right? And typically you want to kind of keep a code base up to date that does the things you want it to do. And it is, you don't generally, yeah, like you said, if you kind of like leave things lying around, they do tend to atrophy, unfortunately. Besides UI, what things are a must-use? Besides UI, what things must use threads in games? Just started learning threads, and I'm curious. There are some things that somehow run slower threaded than single. That's usually not. I would not recommend thinking about threads in terms of what does and doesn't use them. Threads are just ways of taking advantage of extra processing resources, usually in games, because there's two fundamental ways two fundamental reasons why you might be using threads. One reason is because you want something that runs asynchronously, and you just don't want to have to deal with parceling out time to it yourself, right? So you just create a thread and let it do something, and you just count on the operating system to like switch the context so that thread gets some time and run. That's fine for stuff like when you're waiting on the operating system, because oftentimes it doesn't necessarily give you a choice. But I don't super love that as a solution for things inside the game proper. And the reason for that is you can usually be a little bit more reliable by not using the operating system's thread system and hoping that it switches threads for you in a reliable and fashion that doesn't cause frame hiccups or something. So usually the way that the rest of the thread stuff works in games nowadays is by more of like a job system, where you have like some number of worker threads, and you don't create a thread per job. You create a little work order per job, and those worker threads just are constantly chewing through whatever jobs are available. And so typically, I think a lot of times on modern game engines, what you'll see is you don't necessarily have like, oh, we went and put the UI on a thread or something. Instead, you just have lots of work that needs to be done. Those are from different systems. The physics has work to be done, the rendering has work to be done, the entity system has work to be done. You'll see those like getting put into these little work orders, and then those work orders are getting executed by worker threads as fast as they can, and they aren't separate threads necessarily, right? So I think there's really no answer to the question what gets put on a separate thread. It's whatever can be parceled out in efficient work orders nowadays is something that is totally something that could be threaded. The problem with threading things is once you have multiple threads touching a piece of data, it becomes much more difficult to ensure that you don't have bugs that have to do with the order in which the threads do things. On Handmade Hero, we haven't had to wrestle with that too much because we've used threading to a limited extent, and so we've been able to kind of compartmentalize the risk in terms of what has to happen there. When you start getting into systems that have like lots and lots and lots of different pieces that are all doing threaded work, you tend to have to be a little bit more systemic about it and start to have like a concept of like resources or something. It's like, what does this work order need in terms of resources? And let me just like not allow other things to be doing, let me only run this, like don't ever even take this work order and start working on it if those resources are being used by some other work order or stuff like this, right? There tends to be sort of more systemic stuff like that, just because if you actually tried to fine-grain lock everything, while that's going to be more efficient because you can be more clever about it and only do exactly the locking you need and be lock-free in places you don't have to be and all that other stuff, it's just really hard programming. And the chances that you want to write all your code that way and can do it in a way that doesn't have bugs are just real low. Even if you're a very good programmer, it's hard, right? And so that's why you don't just write things as threads like whole cloth all the time. Or as multi-threaded all the time. And so usually you go one of two ways. Either you've got some light multi-thread locking stuff that you've hand-coded because it's very efficient and it works well and whatever, kind of like we were trying to do on Handmade Hero. Or you are multi-threading a huge set of things, and then you tend to have to systemically do it somehow, right? And that somehow can take all kinds of forms. Like maybe it's like something that's built into your language. Like I think Go, for example, has a bunch of sort of primitives that are like, hey, write your threaded stuff this way, and then we can guarantee that it won't cause a problem if you do, because now we have like serialization for those things or whatever. Or it's like, if it's in C++, you've got some like utility structs around that like you say, I'm going to begin doing work on this thing now, I'm going to end doing work on this thing now, and the only way to like get back a pointer to the thing at all is by going through that, so that you know that there is the built-in synchronization happening there or something, blah, 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 blah. Hopefully that answers that a little bit more. For the moment, I have a thread job system. It's for rebuilding a mesh. For a big mesh, it takes like 20 milliseconds, so I thought maybe it would make it faster, but not that much, maybe like 13% faster. Well, usually things don't get faster when you thread them unless you actually have a plan for why they're going to get faster, right? So for example, if you know that you can break the work down into a certain set of pieces that don't have to talk to each other and don't have dependencies, then you'll get that much faster, typically on modern hardware, depending on the circumstances. Certainly, there's other factors. But, so like for our renderer on Handmade Hero is kind of that way. And so for the renderer on Handmade Hero, we do get quite a bit of speed up by having more threads. But if depending on how your mesh building code is written, it depends entirely on how separable that is and how much of it can run in parallel without locking and all that sort of stuff, right? All right, I don't see any more Q colons, so I'm going to go ahead and close things down. There we go. All right, let's go ahead and close that. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org, and it comes with a source code so you can experiment and follow along at home. If you have questions, you can go to our forum site. If you want to support the video series, we do have a Patreon. If you want to know when we're going to be live, we have a schedule bot, and if you would like to catch up on old episodes, we do have an episode guide that has time-coded links, brought to you by the fabulous Miblo, so check that out as well. That is it for today. I will be back here tomorrow, 8 p.m. Pacific Daylight Time or Standard Time. I don't know. Which one are we in right now? Do we know? Time in Seattle. We're still Pacific Daylight Time. So we'll be back at 8 p.m. Pacific Daylight Time tomorrow. Hope to see everyone here for that. I will, the Handmade Hero, the Handmade Con speaker list got posted today. So check that out if you haven't already. You can go to handmadecon.org. Actually, no, you can't. That's a lie. I don't think I've posted it up there yet. You actually have to just go to mollyrocket.com. That's where it is at the moment. That is about it. And I hope to see you back here tomorrow at 8 p.m. Until then, have fun programming, and I'll see you guys on the internet. Take it easy, everyone.